Okay, welcome Year 12. We're going to look at critical path analysis and queuing. So this is going to be our third lesson, and this is now our first lesson on the second half of chapter 9, which is the queuing. So we're going to look at constructing and reading tables and graphs, illustrating queues for one service point today. There's some vocabulary that we need to get our head around first of all. So FIFO, or first in, first out. That means if we're in a queue and we're lining up for a queue, like at a supermarket, if you arrive first, you're going to be dealt with first. Sometimes though, we have LIFO. That means those who arrive last are dealt with first. So if we think of a stack of cards that are dealt with and we're picking off the top, the last card dealt would be the first card out. Likewise, if you work in a retail shop, if you are putting in milk into the front of a fridge, you'll notice that the milk bottles with the newer date may actually be at the front, and so you may have to have a person to organise moving the milk up the back to be up the front, particularly with milk, because it would go off, for example. There are some other terminology we need to think about. Three terms with queuing. Balking is the first one. That is when someone looks at the queue and leaves because it's too long. Reneging is when the customer leaves the queue after waiting too long. So there's a little bit of difference there. That balking is they grab their gear, they look at the supermarket queue, for example, and say, I'm not even going to bother waiting. They leave their trolley and just walk out. Whereas reneging is they actually spend time waiting in the queue, but because the queue is too long, they decide to leave. Now, jockeying is when the customer moves from queue to queue, trying to find the shortest one so they get served in a little bit of a quicker time. Now, the optimum length queue leaves customers both happy, but ensures that service is cost effective. The inter-arrival time is the time in between the customers arriving. The service time is the time it takes to serve the customers. Now, if the service time is longer than the inter-arrival time and there's only one service point, well, that queue is going to get longer. So for our first example, we have a company with only one service point open. The inter-arrival time is 3 minutes. While the service time is 5 minutes. Well, we can see that customers are arriving quicker than they are being served. So you can assume that there is going to be a queue forming. Now let's have a look. Assuming that the first customer arrives at the opening time at 9 AM, construct a table to show the arrival, the queuing, and the service of customers until 9:15. So what we do is we create a table from 9 o'clock to 9:15, and then we start seeing how are the customers served. So we know, what did we say? The inter-arrival time equals 3 minutes and the service time equals 5 minutes. So customer A, 1, 2, 3, 4, 5, is served from 9 to 9:04. At the end of 9:04, it's 9:05. So that's 5 minutes have taken place. Customer B gets served. 1, 2, 3, 4, 5. And then likewise, after 5 minutes, customer C gets served. So, and then D right at the end. Now we also know we have an inter-arrival time. So let's see when people are turning up. So no one arrived in the first minute. Well, I think we'll start our first arrival at 9:03, and then 1, 2, 3 minutes later at 9:06 we have customer C. So D will turn up 3 minutes later, and then E would turn up 3 minutes later, and then F would turn up 3 minutes later after that. Now let's consider the people in the queue. At 9 o'clock, there's no one in the queue. That customer is being served. So there's no one in the queue. So the length of the queue is 0. Same with 901. There's no one in the queue. 902. And let's have a look at 903. Well, there's one person in the queue, and that's customer B. Same as 904. There's one customer in the queue. That B still waiting in the queue. And that would be customer B. So people in the queue is B, and the length of the queue is still 1. Okay, at 905 there is customer A has been served and customer B is now being served. So there is no one in the queue, so the length of the queue is 0. Let's have a look at 906. At 906, who's in the queue? Well, customer C has just turned up, so the length of the queue is 1. And let's have a look here. People in the queue. C's still in the queue here until it gets served here. But if we have a look here, customer D is in the queue at 909. So the length of the queue is 1 until we get to 909 where there's 2 people in the queue. Okay, at 910, customer C is being served. So the people in the queue is D, and 911 is D. At 912, it's going to be D and E. At 913, E turned up, yep. So we have D and E. And then 914, D and E. At 915, E and F, customer F just turned up. So we just count through. So we have one person there, 2 people there, 2, 2, 2. So we have now described, using a table, the arrival. Here's our arrivals. The queuing. And then the service of customers until 9:15. And this is called a customer service table. So according to this table, how long did the 4th customer wait in the queue? Well, the 4th customer is A, B, C, and then D. So the 4th customer is customer D. So we look, they arrived at 9:09. Here they turned up, and they were served at 9:15 here. So we have 9:15, take away 9:09, that's 6 minutes. We can also express this information as a customer service graph. So we can go from a customer service graph to a customer service table and back and forth, but we can also do this from a bit of information. So in this case, we have an inter-arrival time of 3 minutes and a service time of 5 minutes. So we could use the table previously, or we can use this information straight away to draw the graph. In an exam situation, I would recommend that you draw a graph because that shows that you can translate information from text to a table to a graph, and that displays a greater variety of skills, particularly if it's an A-level question. So let's continue now. We're going to have to think about 3 symbols. We have an arrival, we have a wait, and we have a service time. So I'm going to go, here's a little arrival, that's a red dot. And let's say waiting time can be a yellow line, so that's waiting. And then we can have a red line for service. So let's first of all consider the inter-arrival time. So we're going every 3 minutes, and I want a little red dot. So let's assume that customer A turns up straight away. Then at 9:03, customer B turns up. And then at 9:06, customer C, 9:09, D, E is 3 minutes later. You can see that if I join these points together, they should be a straight line because we have a constant inter-arrival time. So I just need to count up and 3s, 15, 18, 21, 24, 27, and 30. So there we have our arrivals. Now we want to think about service and waiting time. So if I think about service time now, the first customer got served and it took them 5 minutes to get served. So I just draw that line there. Now customer B had to wait until customer A was served. So I'm going to draw a waiting line, and then I'm going to draw a 5-minute time for being served. Now after customer B was served, I can now show that customer C is waiting in line, and then they are going to be served up until 9:15. Now customer D is waiting in line, and then they are being served for 5 minutes. Customer E is waiting in line, and you can see that they're waiting in line a fair amount of time now, and then we're going to show them being served. Then customer F is waiting in line, and then they are being served. And these people are still waiting in line. So here's one we prepared earlier. So we can interpret this graph with a few questions now. So first of all, how long did customer F wait? So we're going to look at customer F. How long did they wait? They waited from 9:15 until 9:25. So customer F waited 10 minutes. According to the graph, how many customers were in the queue at 9:24? So let's look at the time being 9:24. How many were in the queue? Well, we've got, reading up here, 1, 2, 3, 4 customers in the line at 9:24. What I would like you to do now is have a go at this example and then practice using exercise 9C on page 475 to 477. Thank you.